Okay, now remember the previous video. You would have to watch them in sequence because you're learning a lot of things by following along with me in the research project of Chronocosmonomy. And in that video, there was two parts of the shadow itself. And in order to answer my question, my own theory was disproved, apparently, by this diagram that I made. So I disproved myself. But maybe I was not disproven. So my original theory is that something is wrong with the shadows. That's why I talk about the shadow itself. Now, when I did this, if you're really smart, you would know that I had a major mistake in here, but that particular mistake does not throw off the disproving of my theory. In other words, it's just a separate factor. So if you don't know what it is yet, what's the mistake in this diagram, and if you've listened to part 1 and part 2 of the shadow itself, and you still don't know, you can put this on pause and try to figure it out, because the next thing I'm going to do is I'm going to tell you what's wrong with my diagram. Okay, if you figured it out, then congratulations to yourself. You're really, really, really smart, and I don't think I'd even be as smart as you. But follow my lead, because I'm the guy that's going forward first, going where angels fear to tread, and I'm going to make a lot of mistakes. So you don't have to. So what's wrong with my first diagram is that I measured the distance from the moon to the Earth as times 30, or 30 times, and that is wrong. It's not 30 times the moon, it's 30 times the Earth diameter. I'm trying to hold the camera right at the same time. So, yeah, I'm doing sloppy because I'm holding the camera with the other hand. Don't have a tripod. I'm not that high tech. So listen, here was the big mistake. I hope that you got that right and you didn't look at something else, because nothing else here is fundamentally wrong. The only fundamental error was this. So, what did I do? I corrected my mistake, which is what you have to do in the scientific method. Check it out. So I corrected it, and then I proceeded to do additional calculations. And you need to take a close look at this, because for students of my class who are seriously learning chronocosmonomy, we still have a major problem. And this diagram, which is the corrected diagram, tells you what the major problem is. Now, of course, because the other diagram was found to be an error with one really bad mistake. Like, how can I remember that the distance from the Earth to the moon is 30 times the moon, but not really, it's supposed to be 30 times the Earth? However, I'm questioning all of that because of this, because the shadow doesn't add up. And by two logical deductions, I can figure out what the mistake is in all of the astronomical knowledge. I narrowed it down to two. There's possibly three logical deductions, but we don't know which one it is. So according to this diagram, which I'm not going to go over in this video like in detail, but you can see it. You can go over it yourself by just freeze framing this. Just take a look at my work here. Just literally take a look at it. You can copy this, debate it, discuss it amongst yourselves, but this is the shocking news for everybody. That what does this actually say? This actually says that the distance to the moon is not known. This says that the diameter of the moon is not known. The only thing that we know from this is that there is an angular relationship of the reduction of the shadow. Let me repeat that. When the shadow from the Earth goes out into space, as it always does constantly, because the shadow is its own entity that exists really independently of everything else, and everybody seems to ignore it. That's why I'm saying the shadow itself is very important. Now, from what we can understand in general, not specific distances or measurements, but in general, we understand that the shadow tapers off. And let me do an exaggerated drawing here. Shadows are like this. Here's the light source, which would be the sun. As far as we know, we're not really going to question that. That's just a primal factor. So if the sun is shining on a celestial body, namely the one that we can observe closest is the Earth, we notice that the shadow is shaped like this. And this is, of course, is exaggerated. This is compressed this way. It's really out like that. It's out like enormously far. But what happens when you compress it, you can more easily see that the shadow tapers off, basically is conical shaped, until apparently, or theoretically, it goes down to nothing, and then after this point, there is no more shadow. This is the umbra shadow, though. Then, and we haven't even analyzed it in this, but there's a penumbra. And the penumbra seems to be different. Well, no, it doesn't seem to be. It is different, but we don't know in what way it's totally different. We don't know that it's conical or flares out, or we don't know. So there's this type of a structure, which is basically telling you that there's an angle here. So essentially, if we, and the angle should be constant throughout. So if the angle is here to this, you would measure it like this. Right? And this angle is how many degrees? How many degrees is this angle of the cone? The part that's not the cone of the shadow. Or you can measure it the other way. It depends on however you want to measure it. There's two sides to this, but they will add up. So what is that angle?